I'm back with a part 2, and we've been talking about sale prices with inequalities solving. So we've talked about how to graph this part. So if you didn't get the first part, check the first part out. This is kind of a longer set of videos, so this is a little bit lengthier than my normal videos. So we were talking about having 20% off and 60% off. So if I have 20% off of the price, then I'm paying for 80% of the game. And if I have 60% off, then I'm paying for 40% of the game. So that is why I have these two numbers instead of 20% and 60%. So what I'm going to do here is take these two numbers of the regular prices and pop them into the X value to find out what would be the minimum value and what would be the maximum value if the number of that game was 20% off or the game was 60% off. So we're going to start off with the 20% off games. So our value would be that it has to be 80% or 0.8 of a $20 value, and then 0.8 of our maximum game price, which is $50. And when I do that, my numbers for this become, this is going to be a $16 game now, and this right here, when multiplied, would give me a $40 game. So for the $20 games and the $50 games at 20% off, my ranges are now $16 or $40 or anywhere in between. So the 20 is going to be 16. So we're going to go, this is 15 right here, so 16 would be just above that. And then we have the $50 game is now $40. So we're going to put that dot right up here. And then that way we can connect those 2 points. And I'm going to do the best I can because honestly I did this with a ruler in the last game and it did not work too well, the last video. So then I'm just going to kind of put this line right here. Now I'm not doing the whole line because this could extend, but in all reality it shouldn't be because these are the numbers from the games. So that's this section. Now, numbers can be less than that. So basically this would now be shaded over here, because that's less. So now this part that we had shaded earlier really is null and void because it's not going to meet the requirement of this new inequality that we just shaded in. Now I got one more to do. So we're going to do the last one, and that is the 40%. So if I do 0.4 times $20, 0.4 times the $50 game, let's see what we get. So $20 game is now going to be possibly $8. Or it would be $8, and then the $50 game would now only be $20. So when I graph these, the $20 game being $8, and this is 10 right here, so I'm going to go, the $20 game is now 8, so it's about down here. And then our $50 game is now $20, so I'm going to go to 20 and 50 and put that. I'm going to connect these two lines, or these 2 points. I apologize for this. Don't do this at home. Make sure you're doing this with a ruler. Okay, now this can be greater than that. So that means that it would be, all of this shaded area would be the true answer for all 4 of these inequalities, because this is the only spot where all of them are blocked out. Now, the question that's being asked is use the graph to estimate the range of possible sale prices for games that are regularly priced at $35. So I'm going to go to regular price at $35. I'm going to look, and it's going to be any set of numbers that falls in here. So right here, this is the spot we're looking at. So anything that is, it looks, well, we can't really quite tell, but we can tell definitely a $15 game. But anywhere from here up to about here. Again, this looks like maybe 27. If I wanted to actually calculate that, I could double check that 100% by just plugging in the number that I think it might be. But if I'm just looking at on a graph, this would be the section right here that you would be focusing on, right in this section right here. And if you want more questions like this, you can find them on my YouTube channel, You Want Algebra. Check them out under the linear graphing systems of linear inequalities section.